Good day everyone. I am Shaimi D. Alivio and this video presentation will tackle about nuclear fission. It is one of the most important topic in nuclear physics. In this video, I will explain what nuclear fission is, how it works, where it is applied. What is nuclear fission? Nuclear fission is a nuclear reaction in which the nucleus of a heavy atom, such as uranium-235, splits into two smaller nuclei after being hit by a neutron. When the nucleus split, it releases a large amount of energy, additional neutrons, and radiation. These released neutrons can strike other uranium nuclei, causing a chain reaction. This chain reaction is the reason why nuclear fission can produce a huge amount of energy. Now, let us understand how chain reaction works. A chain reaction happens when neutron release during nuclear fission cause more fission events. When a heavy nucleus like uranium splits it releases energy and about 2 to 3 neutrons. These released neutrons then strike nearby nuclei, causing them to split as well. As this process continues, more energy and neutrons are produced, creating a continuous reaction. In nuclear reaction, this chain reaction is carefully controlled slowly and safely to generate electricity. However, when the chain reaction is uncontrolled, the energy is released all at once, resulting in a powerful explosion, like what happened in nuclear bomb. So, the key difference lies in whether the chain reaction is controlled or uncontrolled. To understand how the process works, let's go through the steps as we start off with a large unstable nuclei like uranium-235 and we fire a relatively slow-moving neutron. Hazardous addition of a neutron to the nucleus makes it even less stable and causes it to split apart into two smaller nuclei that we call delta nuclei. It also releases two or three more neutrons and importantly loads of energy in the form of gamma radiation. Each neutron can then go on to repeat the process all over again with another uranium nuclei and more daughter nuclei. Energy and neutrons will be released which again allows the process to start over. Now, the key point of this process is that nuclear fission leads to a chain reaction where the first fission can trigger more fission which can in turn trigger even more efficient and so on. If this process isn't controlled properly, then the whole system can quickly get out of control and releases huge amount of energy, which what is exactly what happens in nuclear bomb. So one of the most common questions about nuclear fission is how nuclear fission produces energy. The energy released during nuclear fission comes from the mass defect. After fission, the total mass of the product is slightly less than the original mass of the nucleus. This missing mass is converted into energy using Einstein equation. Einstein equation is represented in E is equal to mc squared, where E is energy, m is mass defect, and c is the speed of light. This explains why even a very small amount of mass can produce an extremely large amount of energy. Nuclear fission has advantages and disadvantages. One major advantage is high energy output. Nuclear fission produces millions of times more energy than burning the same mass of fossil fuels. It also produces very low greenhouse gas emission, which helps in reducing air pollution and combating climate change. Plus, energy power is very reliable. Plants operate around the clock and are not affected by weather like solar and wind power. But despite its benefits, nuclear fission does have challenges. A major issue is radioactive waste, which remains hazardous for thousands of years and must be carefully stored. There are also risks of serious accident if safety is not strictly maintained, like what happens at Chernobyl and Fukushima.
Finally, or lastly, nuclear fuel like uranium is not a renewable resource, meaning it can run out eventually. In summary, nuclear fission is a powerful process that explains how mass can be converted into energy. By understanding its principles, applications, and risks, we can better appreciate its role in modern physics and energy production.